Today we are going to discuss about the hybrid parameters in a two-port network. So what is meant by hybrid parameters? So hybrid parameters are also called as H parameters. Okay. So in shortcut we call it as H parameters. So hybrid parameters are also called as H parameters. So why it is called hybrid? Let's try to analyze. Generally, hybrid parameters are widely used in modeling of electronic components. So these hybrid parameters are used in modeling of our electronic components. So what are those electronic components? Let's try to analyze. Okay. So we have multiple electronic components. So BJT, UJT, triac, diac. So if you want to analyze, okay, so what is their input and output resistance, then this plays an major role. Okay, so modeling is indirectly the analyzing the voltage gain, current gain, impedance and admittance of that electronic component is called modeling. Okay, so that is what the modeling of an electronic devices we use H parameter. So why it is called hybrid parameter? Let's try to understand. Okay, so here we have the equation. Let's try to remember this sequence of writing. So we have V1, I1. So these two parameters are linked with input port. So we have output voltage and output current, which are nothing but related with output port. Now we are linking input voltage with the output current. So the equations are V1 I2, input voltage, output current is equal to, so we have row 1, row 2, column 1, column 2. Ultimately, we are going to get H11, we are going to get H12, we are going to get H21, we are going to get H22, and this is multiplied. So, what are the leftover the values, which are I1 is the input current, V2 is the output voltage, V1, I2 are called independent variables, whereas based on the I1 and V2 value we are going to get V1 and I2. So these variables are called dependent variables. Now let's try to write down. So why it is called H? Of the derivation I will make you the clear. Okay, so here the order of this matrix is 2 rows 2 column. The order of this matrix is we have 2 rows and 1 column. So you can perform multiplication only when number of columns is equal to number of rows. So therefore we can write down the value of V1 is equal to, so the resultant is order is of 2 rows and 1 column. It's exactly the same. So V1 is equal to row multiplied with the column. So V1 is equal to H11 I1 plus H12 V2 is the one set of equation. Second set of equation is nothing but I2 is the output current is equal to H21 I1 plus H22 V2. So these are the ultimate two equations we are having. So now we are going to perform V2 is equal to 0. Whenever V2 is 0, the meaning is the output port is short circuited. Whenever we make V2 equal to 0, this 2 will become 0. When V2 equal to 0, the values we are going to get it as H11 is equal to V1 by I1. Okay, H11 is V1 by I1. So when V2 equal to 0, therefore we are going to get H21. So the value of H21 is equal to I2 divided by I1. So these are the H parameter. So second part, what we are going to make is, we are going to make input current I1 is equal to 0, which means that the input port is open circuited. So whenever it is open circuited, these parameters will become 0 and these parameters will become 0. So whenever these are 0, we are going to have H12 is equal to V1 by V2. Okay, so this is not there, this is not there, and now we are going to have H22. H22 is equal to I2 divided by V2. So I2 divided by V2. So what are the names? So the formula for V by I is nothing but the units are moles. The formula for I by V, the units are moles. So here this is nothing but I2 by I1. So therefore we are going to call this as forward output current by input current. This therefore we are going to call with a name which is called forward current gain. So this is like input voltage by output voltage. So therefore we are going to call this with the name current gain, but this is of reverse. Therefore we are going to call it as reverse, sorry, voltage gain. So generally voltage gain means V2 by V1. So but this is in reverse. Okay. So that's why this is called V1 by V2 is called reverse gain. So since this is voltage by voltage, we have no units here. This is very, very, very important while you are attempting some competitive exams. Here there is no units. So remember, so the diagonal you have ohms and mhos. Here V1 by V2, there is no units. I2 by I1, there is no units. Okay, so that is how to understand. So now this H11 is also called 1 or representing the input. So this is called as input impedance. So 2 are referring output. So this is called as output, and this I by V, this is called output admittance. Okay, so that's how to represent the four different parameters. So after writing in this form, we need to draw the equivalent circuit. So here you can see here one is in ohms, one is in one is in ohms, one is in mhos, and one are having no units, therefore multiple units are combined. So therefore these parameters are named as hybrid parameters. In shortcut it is called as H parameter. So now we have the basic equations as V1 is equal to H11 I1 plus H12 V2 is the one set of equation. So this is nothing but the voltage equation. So here this is an current equation. Okay, the current equation is I2 is equal to H21 I1 plus H22 V2. So now we need to draw the equivalent circuit. So this is a voltage equation. I am applying a voltage of V1, a current of I1 will be flowing. So these are the parameters referring the input port. So here this is nothing but H11 multiplied with I1 with the terminals like this. Okay, and this is a parameter input port referring the output port. So we want to represent this with an voltage source. Okay, so automatically this is positive and negative. This is H12 V2. So if you apply the KVL, so the voltage at this point is V1, current is entering as positive, leaving as negative. So this should be positive and negative. When you apply the KVL, the voltage is plus V1 minus I1 into H11 minus H12 V2 equal to 0. Therefore, V1 is equal to I1 H11 plus H12 V2. So hope from this you got this, and by cross verification also this is 100% correct. The equivalent circuit for the input port is correct. So output port we have the KCL. So this current I am going to write down this as I2 is equal to Ix plus Iy. So how we are going to draw this one is I2. So we are having an output voltage of V2 and it drives a current of I2. So the value what we have here is nothing but Iy. So this I am going to draw like an impedance with a value of H22. So what is the voltage at this point is V2. The voltage at this point is also V2. So we have been drawn the output port parameter, but we want to draw the input port parameter. This should also be a current. So we are going to represent the out at output port. We need to represent input port parameter I1. So how to represent this one is, so we want to show the current in downward direction. The magnitude of this source is Z21 I1. What is the type of this source? So H21 I1. So this is called current control or current current dependent. What kind of source? Current source. Okay, so what kind of source this is? Voltage dependent. What kind of source this is? Voltage source. So now we are going to join the output with the input. So this is the equivalent circuit of our. So this is the equivalent circuit of our H parameter model. Okay, so this H parameter model is nothing but, since it is combined with ohms, mhos and no units, so this is called as hybrid parameter. It is especially used in modeling of diode, modeling of transistors, modeling of bipolar junction transistor, triac, diac, all the electronic modeling required. We need to find out in all this electronic circuit modeling what is the input impedance offered by the element, what is the output admittance offered by the electronic devices, what is the voltage gain offered, what is the current gain offered, or it's nothing but voltage gain is nothing but amplifier. So all the time you have to see that current I is equal to V by R. Okay, so generally they has to offer high resistance, therefore lower current only will flow. So the equipment has to be designed with high resistance or high impedance. Automatically it can take only less amount of current. So then I can say that electronic devices will, so here whenever the current is lower, therefore I square R is also low, therefore power loss in that component is also less, or the power consumption is also less. That is how to understand the components are interconnected with each other. So whenever we see this plays a major role in analyzing all the electronic components. H parameter model plays a major role. Hope you understood the concept very clearly. If you feel the content is useful to you, please give a like, please share with your friends, and if you have a doubts, please comment. I can answer your comments. And if you're watching for the first time, subscribe to the channel. This is a good channel and a free channel for the benefit of students as well as the faculty. Hope you understood well. And this is the equivalent circuit. So this is the equivalent circuit of our H parameter model. So this is how to represent the H parameter model. Thank you for watching. We'll meet in the next video.